Okay, this is my lecture video for section 5.6, solving radical equations. I can solve radical equations and inequalities, and I understand how to check and identify if a solution is extraneous. So there are steps involved. They will be to get the radical on one side of the equation by itself. We will then use exponents to undo the radical. We will solve the resulting equation, and then last, we must check for extraneous solutions. What is an extraneous solutions? They are extra solutions. They extraneous solutions are results found by solving an equation that do not work in the original equation. They are extra solutions. These extra solutions are created when an intermediate equation has more solutions than the original equation. For example, x equals negative 3. That is an equation, and it has only one solution, okay? And that would be x has to be equal to negative 3. However, if both sides are squared, so this happens when that intermediate equation has a square in it. That's when this happens. X squared equals 9 is an equation that has two solutions. You could have negative 3 or 3, but not both of them may not actually work. So the process of squaring an equation, this happens when we square, can produce an extraneous solution. So when equations are squared, the prospective solutions need to be checked, and we're going to show you what that means to see if they're truly solutions. So it doesn't happen, by the way, if it's an odd power. So if it's to the third or to the fifth or to the seventh and so forth. So let me show you some examples. So how um, let's start with letter A. I have 6 minus the square root of x minus 3. We need to solve this equation. So this is the radical, and we need to get it by itself. And so what will we do? We need to get the 6 over to the other side. So we're going to subtract 6 from both sides. And then we will have a negative square root of x minus 3 equals negative 5. I'm going to divide both sides by negative 1. Or I'm sorry, I could multiply both sides by negative 1. Then I get the square root of x minus 3 equals 5. Now, in order to get rid of the radical, I need to square both sides. When I do that, there's that intermediate um, equation, and we will have x minus 3 equals 25. Then I need to add 3 to both sides, and I get x equals 28. I need to confirm that 28 is a true solution, okay? So we're going to take 28, and we're going to plug it back in here, and we will check that 28 minus 3, which is 25. The square root of 25 is 5. 6 minus 5 is 1, and so we get 1 equals 1. So this is a solution, and we are done. We have followed our procedure, and x is equal to 28. Okay, you can try one yourself. Welcome back. Square root of x plus 2. Let's get rid of that 4. We're going to subtract 4 from both sides. 7 minus 4 is equal to 3. In order to get rid of that radical, I need to square both sides. So I have a square in the middle or throughout this process. So I need to check for extra solutions. So I get x plus 2 equals 9. I need to subtract 2 from both sides, and I get x equals 7. And I will then, the last step is to confirm that that 7 is truly a solution. So 7 plus 2 is 9. Square root of 9 is 3. 3 plus 4 is 7. And so we, sure enough, we get 7 equals 7, and so it works. And that's, you don't have to show that, but you definitely need to check it yourself, because otherwise you would have to write no solution. And we'll work one together that has that happen. So back up there, x is equal to 7 is your answer. All right, C. All right, I have a radical. It's in the form of a fraction. That 1/3 is the same as the cubed root. I need to get that radical by itself. And so how do I do that? First thing I need to do is add 4 to both sides. And so I'm left with 2 times 6x minus 3 to the 1/3 power is equal to a positive 4. I need to divide by 2 to, on both sides, and I will get the answer uh, that is equal to 2. Okay, now how do I get rid of this 1/3 power? Let me clean this up a little bit. I get 6x minus 3 to the 1/3, which is the same as the cubed root. I need to cube it. And if I cube one side of the equation, I must cube the other side of the equation. So if I take 1/3 to the 3rd power, we multiply and the 3's will cancel and I will get 6x minus 3 and 2 cubed is equal to 8. I add 3 to both sides. I get 6x is equal to 11 and I find that x is equal to 11 over 6. Now, um, this was to an odd power or to an odd root. And so we do not have to check for extra solutions or extraneous solutions. But it's not a bad idea to confirm that 11 over 6 is a solution. So 6 times 11, 6. The 6 is canceled. 11 minus 3 is 8. The cubed root of 8 is 2. 2 times 2 is 4. 4 minus 4 is 0. And so 11/6 does, it satisfies the equation. It is a solution. It's not a bad practice, but you don't have to do it if it's an odd power. All right, D, your turn. Welcome back. First thing I need to do is get this term that is in the radical by itself because it's to the 5th root. And so I need to subtract 4 from both sides and I will get 5n minus 3 to the 1/5 is equal to 6 minus 4 is 2. I now need to take this. How do I get rid of the 5th root or um, this binomial raised to the 1/5 power? I need to take it to the 5th power, and I need to take the right-hand side of the equation to the 5th power. So 5 times 1/5 is 1, and I will get 5n minus 3 is equal to 2 to the 5th power is 32. So it's the same as 2 times 2 times 2 times 2 times 2. So that's 4 times 4 times 2. So 16 times 2, 32. I will then add 3 to both sides of the equation, and I get 5n is equal to 35. And then I will divide by 5, and I get n is equal to 7. I need to check, well, actually it's to the odd power. I don't have to worry about extra solutions, but let's just check it anyway. So 7 gets replaced, or we'll go in for n. So 5 times 7 is 35. 35 minus 3 is 32. The 5th root of 32 is 2. 2 plus 4 is 6, and that is a solution. All right, let's do another one. Okay, so this problem has 2 radicals. I have one on each side of the equation. And how you solve an equation that has 2 radicals is first isolate one of the radicals and then get rid of it using exponents. And then isolate the second radical and do the same thing. So it already has the one of the radicals isolated. It already has one of the radicals isolated. So we are going to take and square both sides of the equation to get rid of that square root. And that will result in x minus 12 is equal to, and if I take what's in parentheses and square it, that's the same, that by definition, that is that binomial multiplied by itself. So now we have to do our FOIL first, outer, inner, last. And so that will result in 2 times 2 is 4. The inners will result in negative 2 times the square root of x. And the outers, which are the last terms multiplied by each other, will be a positive x. So negative times a negative becomes a positive. Square root of x times square root of x gives us x. And then we will simplify this equation. So, okay, now the step is to get this radical isolated by itself, okay? So I'm going to subtract x, I'm going to subtract 4, I'm going to subtract x, I'm going to subtract 4, and I will get on the left-hand side, negative 16 is equal to negative 2 square root of x. Divide both sides by negative 2, I get a positive 8, unless I did something wrong, and that will equal the square root of x. I will then, hold on, where am I at? Oh, I see what I did wrong. Okay, made a math error. That is not 2x, that is a negative 4x. I knew I did something wrong. Okay, when I divide 16 by negative 4, or negative 16 by negative 4, I get a positive 4. There we go. All right, now I need to square both sides of the equation, and I find that x is equal to 16. Now we need to check our answer. Okay, so take 16, let's plug it into this x right here, and what do we get? We get 16 minus 12, which is 4, and the square root of that is 2, and then question mark, then we take 16 and we plug it into this x. So we get 2 minus, the square root of 16 is 4. So 2 minus 4 is negative 2. Okay, that does not equal, that is no. And so this means that we have no solutions. So where did this come from? So if I were to have squared both of these, we could see that 2 squared is 4 and negative 2 squared is also 4. So this is an extra solution that was a result of the fact that we had a square equation that was intermediate to the solution. So there is no solution to this problem for E. That is the correct way to state your answer. All right, F. Again, let's talk about the steps. The steps are get the radical by itself, use exponents to undo the radical, solve, and then check to see if you have a true solution or if it's an extra solution. So what do we need to do? One of the radicals is already isolated. So let's go ahead and square both sides. So I get x minus 3 is equal to, and now I have x plus 4 under the radical minus 1 times the square root of x plus 4 minus 1. And so we'll do a FOIL, first, outer, inner, last. And so when I multiply the first terms, I just get x plus 4. When I multiply the inner terms and add them, I get negative 2 times the square root of x plus 4. When I multiply the outer terms, I get positive 1. And on the left-hand side, I get x minus 3. Now I need to isolate the second radical. And how do I do that? I subtract x, I subtract 4, and I subtract 1. So I'm subtracting x, I'm subtracting 4, and I'm subtracting 1. And so that will simplify into negative 8 is equal to negative 2 times the square root of x plus 4. Divide both sides by negative 2, and I get a positive 4 is equal to the square root of x plus 4. I now need to square both sides of the equation to get rid of that radical, and I get 16 is equal to x plus 4, or x is equal to 12. All right, we now need to take this 12 and we need to plug it into our original equation to test to see if it is a true solution. So the first side of the equation is 12 minus 3, which is 9. The square root of 9 is equal to 3. And then we're going to test the right side of the equation. So 12 plus 4 is 16. Square root of 16 is 4. 4 minus 1 is 3. And sure enough, that works. And so this is a true solution to the equation. Try one yourself. Welcome back. We're going to square both sides of the equation. and I get x minus 10 is equal to, we will FOIL first, enter, so negative 2 times the square root of x, and then last, positive x. I will then simplify by subtracting 1 and x from both sides, and I get negative 11 is equal to negative 2 times the square root of x. Okay, divide both sides by negative 2, and I get 11 over 2 is equal to the square root of x. Square both sides to get rid of the radical, and I find that x is equal to 121 over 4 is equal to x. I now need to test this answer, so I will plug it into the left-hand side first. And what do I get? I get the square root of 121 over 4 minus 10. Well, 10 becomes 40 over 4. And so that is equal to 121 minus 40 is 81. And then I have that over 4. And so that left-hand side will give me 9 over 2. And then on the right-hand side, I take again and plug that into for x. And I get the square root of 121 over 4. So that will give me 1 minus 11 over 2, which is the same as 2 over 2 minus 11 over 2, which gives me negative 9 over 2. And so we find that 9 over 2 does not equal negative 9 over 2. And so this solution that we found is one of our extraneous solutions. So this is no solution because of this, okay? Now, if I were to have squared both sides, I would have gotten 121 over 4 equals 121 over 4. And so there you go. This is the answer, no solution. All right, 3 more to go. Similar type of thing, except that now we are solving radical inequalities. So you must determine the domain to see which values are allowed. It is a very good practice also to verify that the solution obtained makes the inequality true. So very similar process. So in letter A, as you can see, I have an even radical and we have a domain restriction. We know that 5x minus 10 cannot be a negative number. It has to be greater than or equal to 0, okay? So again, I can't take the square root of negative 4. There are no two numbers that multiply each other by itself twice to give me negative 4. So if that's the case, I can then find that the domain has a restriction. So I'm solving for it right now. I get x has to be greater than or equal to 2. This is my domain, okay? Now I can go through the steps for A, just like what I had done before, by isolating that radical. So we will subtract 3 from both sides. So I get 5x minus 10 is less than or equal to, and 8 minus 3 is 5. And then I need to square both sides. And I get 5x minus 10 is less than or equal to 25. I need to add 10 to both sides. And I get 35. And then I divide by 5 from on both sides, and I find x is less than or equal to 7. Well, x is less than or equal to 7, but x also has to be greater than or equal to 2. So the solution is 2. Let's see, yes. So 2 is less than or equal to x, which is less than or equal to 7. So we have to combine the domain that we found, the domain restrictions, along with the solution, okay? Now, it's wise to check both of these limits. So if you plugged in 2, I get 5 times 2 is 10. 10 minus 10 is 0. The square root of 0 is 0. So 3 is truly less than or equal to 8. If I plugged in 7, I get 35 minus 10, which is 25. Square root of 25 is 5. 3 plus 5 is 8. And sure enough, that is equal to 8, and it meets It is true. All right, how about B? Let's first start by finding our domain restriction. This has to be greater than or equal to 0. What's under the radical? Because it's even. So 2x is greater than or equal to -2. X is greater than or equal to 1. This is my domain restriction. All right, now I'm going to do exactly what I have done in the past and isolate that radical. I do that by subtracting 1 from both sides. I then square both sides of the equation to get rid of the radical, and I find 2x plus 2 is greater than or equal to 16. I then subtract 2 from both sides, and I get 2x is greater than 14, and I find that x is greater than or equal to 7. Notice this domain restriction says that x has to be greater than or equal to 1. So it does not alter what we found as our solution because 7 is greater than -1. But we should test it. So 2 times 7 is 14. I'm testing it in the original equation. 2 times 7 is 14 plus 2 is 16. Square root of 16 is 4. 4 plus 1 is greater than or equal to 5. Okay, try one yourself. Welcome back. First thing you should do in this kind of problem is find your domain restriction. This has to be greater than or equal to 0. Okay. And what do we find that domain restriction to be? Greater than, and x has to be greater than or equal to 1. Now I solve this problem just like I have in previous equations with radicals. Well, we need to isolate that radical, so we're going to add 2 to both sides of the equation, and I find that the square root of 4x minus 4 is less than 6. Now I can square both sides of the equation, and I find that 4x minus 4 is less than 36. I have to add 4 to both of the sides. 4x is less than 40. X is less than 10. Now, I need to combine this domain restriction with the solution that we found. And so x has to be greater than or equal to 1. And x has to be less than 10. Notice, don't forget, 1 is less, it has an equal sign, 1 does not. So this is my answer. Now I should check those by inputting those limits into the original equation.